So in this video, we're going to discuss how to find the volume of a solid. A solid is a three-dimensional figure with known cross-sections. And so what I mean by that is in this first picture here, your cross-sections are squares, kind of coming up perpendicular to the x-axis. In this second one, we've got yellow triangles popping up. In this third one, we have semicircles as our cross-sections. And this last one here, you have blue rectangles. And you want to consider an infinite number of those and imagine what that cross-sections would look like and what 3D solid you'd have. Now, you could also have semicircles like this popping out. Again, you've got semicircles on the left, and on the right, it looks like you have equilateral triangles. Now, how do you decide what these cross-sections look like? Well, the base of your cross-section is going to be the distance between your two curves. So here's one curve, here's another curve, and that distance right here of that rectangle or that square is going to be the distance between the two curves, and then that height depends on the problem. Okay, so in this example here, we have a circle, and the length of our squares are going to be the distance that you've got across from the semicircle, and then you've got that square popping up out of that circle. So definitely a little tricky to visualize, but I hope you're kind of getting the hang of what these look like. Here on the left, we have squares as cross sections, and on the right, it looks like we have isosceles triangles or maybe equilateral triangles. Here we have semicircles. And again, you want to imagine an infinite number of those cross sections so it's completely filled in. That's what we're really finding the volume of. So what's our formula? We'll go ahead and get this right down. Basically what we're going to do is we're going to calculate the integral from a to b, and I'll explain what those are in a second. But most importantly, we're going to take the area of the cross section, and that's what's in our integral. So this is going to be the area of the cross section. And this dx stands for the width or the depth. So really, when we have the area times the width or the depth, or we can even think of it as the height, this is going to give us volume, because we know that the area of this times its thickness or its depth or its width, whatever word you want to use, that gives us the volume. So we're basically summing up the volume of every cross section. What do you need to know here? From this slide, you need to know that we're going to integrate the area of the cross section. That's how we find the volume of these figures. So here's our first problem. Find the volume of a solid whose base is bounded by a circle. X squared plus y squared equals 4. And now we have cross sections that are squares, and these squares are going to be perpendicular to the x-axis. So to do these problems, we first have to draw a picture. Then we have to find the area of the cross section. We determine our bounds, and then we integrate. So let's first start by talking about what this looks like. That's a circle, and our circle formula is x squared plus y squared equals r squared. So here my radius is 2, because if r squared is 4, my radius is 2. So I'm going to draw from -2 to 2 a circle. And then I have cross sections that are squares. So I'm basically going to have the base of my square being that green line, and then I'm going to have a square kind of coming and poking up out of it. So you've got a green cross section right there. It's a square popping up, and you have an infinite number of those. Well, to find what the length of our square is, we need to know what our equation is. And so let me just go ahead and give another color here. So this right here represents this, okay, and then we'll call this the blue. This is going straight up in the air. That's this right here. So I'm going to bring you to Desmos and explain to you what each of these are. So what you can see here is in red, I have the equation x squared plus y squared equals 4. But if I solve for y, meaning the height from the x-axis up to my red line, this top equation can actually see in blue here. This top of the circle is represented as the square root of 4 minus x squared. So I can't use my pointer here, but look on the left of the screen. That blue semicircle on top is the square root of 4 minus x squared. And then that bottom circle is actually a negative square root of 4 minus y squared. And if you're wondering how I found that, I basically solved for y. So going back here, I basically, if I solve for y, I get y squared is equal to 4 minus x squared. Then I square root both sides, and I get y is equal to the plus or minus the square root of 4 minus x squared. So in this top equation right here, this one right here, the equation of that blue line is the positive square root of 4 minus x squared. And then the bottom of my semicircle, this right here, that's the negative square root of 4 minus x squared. So the question is, what is the length of my purple thing? Because I'm really trying to find out what the area of my square is. So I want to know what the base of this thing is right here. Well, that's going to be 2 of these. Right? Because one of them from here to here, let me go a different color. From here to here is a 1 square root of 4 minus x squared, but I want to know what 2 of those are. And so that's going to be 2 of these. So this represents 2 the square root of 4 minus x squared. And of course, the height of our square is going to be the same thing as the base, because by definition, it is a square. So this is going to be 2 and then square root of 4 minus x squared. So my answer, the volume of this shape, is going to be the integral from minus 2 to 2. You're going to use those x values because we're perpendicular to the x-axis. And then you're going to have the area of your square in here. Well, my area of my square is base times height, or in this case, it's going to be 2 times the square root of 4 minus x squared, and it's going to be this entire quantity squared. Basically, base times height, which are the exact same. And all you have to do, folks, is do this on your calculator, and you will get the volume of this three-dimensional solid. Now, if you're a little confused about how I got this 2 square root of 4 minus x squared, there actually is an alternative way to do that. And you can think about when we were finding the area between curves, that if I want to find this distance right here, I just do the top curve minus the bottom curve. So that would be the square root of 4 minus x squared minus negative square root of 4 minus x squared. Well, that minus minus is going to become a plus. Okay, and that's going to give me 2 square root of 4 minus x squared. Or, of course, you can see that it's going to be 2 of the top curves. All right, so there's our first one. Yeah!